Hey guys, for this video we are going to talk about the central angles of polygons. This is a pretty basic concept, but it is the focus of most of the MyOpen Math problems for today. So first I want to give you guys a good little visual of what the central angle even is, like what is it even talking about. So if I were to draw a line from the center out to each vertex of these polygons, right? Starting with this pentagon. That one's a little off. Alright. A central angle is then each of these. These are all examples of central angles, and they're all the same measure. Alright, each one of these are congruent because all of these are congruent triangles, and the reason for that is because we are only working with regular polygons, meaning all the sides are the same, all the angles are the same. So hopefully you see that when all of these are right next to each other, that's really ugly, when all of these are right next to each other, they create a perfect circle. Okay, I'm like, that's really bad, I'm so sorry. It's not going to be good, I've just accepted that. Alright, all of these create a circle, and so each of these is considered a central angle. Okay, and the whole idea here is that because all of them together create a circle, that tells us that the central angles all add up to 360, right? And so if I wanted to figure out the measure of one of them, that means that I'm going to be essentially distributing all 360 degrees amongst however many angles there are. Okay, and the whole point is that we are going to see what the formula is for the central angle. But I want to show you that it applies to all of these polygons. And bear with me while I draw these lines. Alright, so here as well, we have our circle in the middle. It doesn't matter how many there are. Okay, this works for all of them. I'm not going to bother with that one. So, we know then that all the central angles add up to 360. So to get one central angle, we just have to divide that 360 by however many triangles there are, which means we're dividing by how many sides there are, because the amount of triangles matches the amount of sides. So this is the formula for central angle. So let's see some examples of what this is going to look like. So calculate the central angle for a six-sided polygon. That means all I have to do is 360 divided by 6. And I'll give you a good visual for that. Here's a six-sided polygon. Here is some central angles. Alright, here's all my triangles drawn in there. And one central angle is going to be this right here. This is what I'm calculating. So 360 divided by 6 is equal to 60. So that tells me that my central angle right here is 60 degrees. It also tells me that all of these are 60 degrees. Right, because they're all equal. And that's all for that. Let's try another one. Calculate the central angle for a 17-sided polygon. 360 divided by 17. You're going to need your calculator for some of these because sometimes you can get decimal numbers. So 360 divided by 17 is going to give us about 21.18. Okay. And that's it. Let's do one more. A 13-sided polygon. So 360 divided by 13. This is another calculator question. We end up getting about 27.69 degrees. Alright, that is it for this video. I just wanted to do a brief little central angle demonstration. If you are struggling with the SOHCAHTOA problems on MyOpen Math for today, then go ahead and reference the other original SOHCAHTOA video that I have linked in the tab.